Hi, my name is Sean Healy. I work for the Rocky Mountain Research Station Inventory and Monitoring Program. This is the second of a series of 2 videos about carbon in the National Forest System. The first video was really an orientation around carbon issues and trying to decide what the best available science is for supporting assessments going into the planning process, the 2012 planning process. This video is really addressing how to use 2 reports that have been put out by the Office of Sustainability and Climate Change. The first of those reports is baseline assessments of carbon stocks, and the second is influence of disturbance management activities and environmental factors. And before I get into it, I just want to mention there are several people who have put in a lot of work for this video. A couple extra people from the last video. Their names are printed there. Okay, so these are the 2 reports I just mentioned. They should be available to you as a planner. The first one is on the web already, and the address is there, and perhaps by the time you see this video, the second one will be as well. I know that the first one is Googleable, so you should be able to find the second one as well. So the first video there are 3 things that I want to carry forward from the first video. The first is that the planning rule is relatively flexible in terms of what the baseline carbon assessment contains. So there is no one template that will serve everybody. And carbon is one of many ecosystem services. The planning rule doesn't mandate that you manage for carbon, but it does mandate that you have to assess carbon. And the assessments should be tied to the trends and issues of greatest local interest. So our intent behind these reports was to give people a nationally consistent baseline, basically a menu that you might choose from to talk about carbon in your assessment supporting the planning process. Like any other menu, you're not going to choose everything. You're just going to choose what's right for you. So those are really the take-homes from the first video. And before we get into the carbon assessment itself, and by that I mean the tools that are available in the carbon assessment, it's probably worth looking at the resources, the data resources that have gone into the 2 carbon reports. A couple of reasons. First, it's useful to understand the monitoring data that is supporting each of these tools. If you saw the first video, we put a lot of thought into choosing the tools that maximize the use of empirical, local, representative data. And in this video, I'm going to talk a little bit about what that data is. And the second reason to talk about right up front about what the monitoring data feeding this process is that it might be relevant for you in other fields. And you'll see what I mean. There's disturbance products, vegetation products, which might be relevant in things like habitat monitoring, veg monitoring, maybe timber supply monitoring. So we're going to dive right into the data that we've collected, and each of these, if the graphs that I'm showing are lifted directly from the reports, there's a little orange rectangle at the upper right telling you which of the reports. And the first report, again, is the report about carbon stocks, both in the ecosystem and in the product chain. And the second is talking about the relative effects of disturbance and management on those carbon stocks. So if one of the things you see has one of these little rectangles, it means you can go right into the reports and find this for in most cases, it's for your particular national forest. And for a couple of them, and I'll tell you which ones they are, it's only available at the regional level. So, the first thing that we put together was FIA analysis for each national forest. And what you see here which is presented in the second report, is for the Flathead National Forest and the Ouachita National Forest, just two different parts of the country, an age distribution and also a forest type group distribution for each of those forests. And this comes right from FIA. I mean, you can do this for yourself. FIA has an online tool that allows you to do this fairly easily. But we did it for these carbon assessments, and the results are provided in these reports. So, and they tell interesting stories. For instance, in the Flathead, you can see a peak that represents recovery after initial Euro-American settlement. And it also shows you in the younger age groups the effects of recent fires. And it might also be interesting to note, the distribution across different forest types. On the Ouachita, for instance, you see a big peak recovery following a period of intense logging and reversion to agriculture. So those are some of the take-homes you might take away from the basic monitoring data that is presented in that report. There are also maps associated with this. We clipped out national forest boundaries, and these maps are not presented necessarily in the reports, but they're available, and my contact information will be at the end of this video, so you can contact me and I'll make sure you get these if you want them. Another kind of map that was produced, and this is really central to almost everything that is in the second report, is a series of 30-meter maps of disturbance by type, by year, and by percent canopy cover removal. And in the lower right, you can see results. For instance, I happen to be in Colorado. In this part of the country, this map shows the incidence of insect activity, and so this is really a hot spot for that. And there are other maps for harvest and for fire as well, and they show up in different parts of the country. But here's the important thing for these maps. It's 30-meter map. It's consistently processed across the entire national forest system. And we had a person, a technician, literally look on a stand-by-stand scale at a lot of different evidence to identify disturbances that have happened every year from 1990 to 2011. And so the different types of information that those technicians were looking at, the MTBS, Monitoring Trends and Burn Severity database, it's a fire database, the aerial detection surveys, basically insect, these are all Forest Service institutional investments in monitoring that we're bringing to bear here. Also looking at medium and high resolution imagery, and NFS's own activities database, FACTS, as well as a time series of Landsat imagery that I didn't put up here. So basically, we had a technician manually editing change polygons across your national forest from 90 to 2011 at a 30-meter scale. It's not perfect. I'm sure there are errors in it, but it is very close to the best you're ever going to see for anywhere, actually. So it's easy to see how this might be linked. I mean, I'll show you how it's linked to carbon monitoring, but it's easy to see how a map of disturbance might be linkable or useful for looking at things like habitat. In fact, I used maps much like this for the Northwest Forest Plan, looking at spotted owl habitat. So there are a lot of ways outside of carbon that this stuff can be used. So we can summarize the disturbance maps in tabular form. And in fact, we have in the second report, you can find these tabular summaries both at the regional scale and at the national forest scale, like a lot of the results that I've just talked about. So In this case, we're looking at the Flathead National Forest, and what we see is that the maps tell us that, we've had some pretty large fires in the early 2000s and again in 2007. That insects are starting to peek through towards the end of the time period, and that harvests happen at a relatively low level through the 90s and the 2000s. On the right, what we see is the same disturbances broken down into magnitudes. So we've got a distribution of pretty light disturbances, class 1, that's 0 to 25% canopy cover change, or canopy cover loss, CC loss, all the way through class 4, which is 75 to 100% canopy cover loss. So take-home messages that you might get from this summary is that since 1991, fire has been the most dominant disturbance type in this national forest. There were large fires and those fires were pretty high, medium, and high severity in 2002 to 4 and also in 7. And that also in relation, harvest and insect outbreaks have been relatively small. So again, these are found in the second report. So something that is found in the first report is a record of timber product output. And this has really been the product of a lot of searching in filing cabinets across the country. This was led by Keith Stockman in Region 1. And basically what we've got is a nationally consistent report of timber product output for each region. And this is the one, I said I would mention it, this is the one type of information that we have not gotten down to the forest level, except for Region 1. Every other region is reported at the regional level. And so basically what we've got here, the y-axis is timber product output in both megagrams of carbon and also in million cubic feet. And the story that it tells, this is Region 1, the northern region, but it's very similar to most of the other regions. Post-war extraction was that was the peak of the extraction. And there's been significant decline in harvests since the early 90s. So if you want this information, this seems like this would be great information for timber monitoring, timber product monitoring. It's in the first report, and you'll see in a second what we've done to this to extract the carbon story from it. Okay. Lastly, what we've also put together is climatic and atmospheric trends for each national forest. So we've basically taken downscaled climate and atmospheric data and summarized it by the national forests. So and these also can be found at the national forest scale and I think also at the regional scale in the second reports. And so basically you can see a trend for precipitation, although not much of a trend in the Flathead. Trend in temperature, which is a little bit more pronounced in this forest, and certainly a trend in nitrogen deposition. So, we use this in assessing the factors that influence carbon storage, but it might be interesting in other types of monitoring as well. So, to summarize, this is a point made in the first video. We are looking for tools that answer a particular question and are as far to the right on this graph. That is, they're based as much as possible on comprehensive observations that are collected at the local level. And so, what I'm going to do now is focus on each of the 4 tools that are reported in these reports and talk about the kinds of questions that they are most appropriate for answering. So keep in mind that for every question, we're really trying to pick the tool that is the farthest to the right on this graph. So we're going to start with FIA CCT, and I'll tell you what that stands for in a second. But This is the type of question that FIA and CCT really perfect for answering is how much carbon is out there on the landscape. So CCT stands for the Carbon Calculation Tool, and it's really what FIA uses, the Forest Inventory and Analysis program of the Forest Service. It's really what the Forest Service uses to report our country's carbon stocks to the UN, and it has been pointed at each national forest. And it's really based upon FIA data. FIA data is over 125,000 permanent plots across the country. That's about one every 6,000 acres. It's a design sample, so it's basically a simple random sample, or treated as a simple random sample. And so it provides really straightforward ways of figuring out what your uncertainty is. There is a little bit of modeling required to go from FIA to CCT, and that modeling is related to figuring out how much carbon is in pools that we don't necessarily sample at that intensity. For instance, how much carbon is in the roots. We definitely don't dig up every tree we measure, so there's a little bit of modeling involved in there. And there's also some interpolation that happens between FIA's periodic visits to every plot. And as I said, this is what the country uses to report its carbon. So it's been applied to the National Forest System, and it gives us some really good information. It breaks down how much carbon each national forest is storing into the different components of the ecosystem. So how much is stored above ground, below ground, in the understory, etc., and how it has changed. And this is another type of information, again, that is reported. This is in the first report, both at the regional level and at the national forest scale. So in the upper right, I just want to, this is basically an interpolation of the carbon stocks for the Idaho Panhandle National Forest. I said that FIA and CCT really lend themselves to good uncertainty estimates, and what you're seeing here is the standard error presented around each of the stock estimates over time. So, take-home message from this forest, for instance, you might say that, or you might observe that slow growth is apparent in all pools. But the sink source status is, if you look at that line, it is trending a little bit upward, but given the uncertainty estimates, I wouldn't bet my life on it. So, if anything, you could say that it's neither a strong sink nor source. If you were to use the conversion factors I presented in the first video, this 200 teragrams of carbon in this forest, which you find in this graph, is about equal to 200, well, it is equal to 200 million metric tons, or 1.7 trillion barrels of oil worth of carbon that this national forest is storing. Okay, so so that's FIA CCT. Very basic what's out there, and very straightforward reliance on a design sample. So then we've got estimates of product carbon, that the process that we use, which I'll talk about in a second, is answering that question. It's also very descriptive. How much carbon is in the product pool now, and how has that changed? So drawing on the timber product output information that I showed you earlier, we put that information through, it's basically a simple life cycle analysis model that was developed by the Forest Service's Forest Products Lab. And it's basically just a very simple accounting of how much carbon has been put into the product pool over, going all the way back to the beginning of this national forest. And we know about how long carbon stays in each of the pools, each of the product pools. For instance, product pools related to construction last much longer than paper, for instance. So we break it down, we break the timber product output down into various individual pools. We track them over time, and we have a pretty good idea of when they get discarded and then when that carbon is released into the atmosphere. And what we see here, I think this is for region 1, is that, but it's also pretty typical of all the regions, is that storage in this pool peaked around 2000. You might remember that I showed you that in the 90s there was a slowdown in carbon. So there's sort of a lagging benefit to that, to the amount of carbon that we put into product pools. And after that peak, the amount of carbon is slowly decreasing. And you can see the breakdown between the amount of carbon that's still in use and the amount of carbon that's in solid waste disposal systems. That's what SWDS stands for. Okay, just another side note here. I had one of these in the first video. The idea is that you can use these calculations to compare between different results, and also to relate results to things that the people that you're reporting to understand. So side note here, I think it's really interesting to compare the amount of carbon that's stored in the product pools versus, which is really, that might have grown a lot of decades ago, is currently being stored in forest products. How big is that pool compared to what we see on the stand? And so in region 1, the first report states that in a different part of the report, we've got about 1,400 teragrams. And also in the first report, you see that the carbon in this graph, 30 million megagrams, or 30 teragrams. So the amount of carbon stored in products is about 2% of the ecosystem stock. So that's an example of how to compare results within the same report to get some good context. Okay, so moving on to a little bit more complex question. How has management and disturbance affected total carbon? So this is getting a little bit more complex than just what's out there and how has it changed. Now we're talking about what are different ecological and management-oriented processes, and how have they affected what's out there. And for that we have FORCAMP. FORCAMP stands for Forest Carbon Management Framework. And basically it is highly tied to FIA data in a number of different ways. I guess the first thing to realize is that it starts with a map of forest conditions across the national forest. And that map is constrained in important ways, and if you're really interested in how there are citations in the reports that talk about, that will point you to papers that describe how these maps are constrained to FIA. But we start with a spatial visualization of the forest conditions across the landscape. And then we bring in the maps of disturbance that have happened, that show the disturbances that have happened since 1990. And we essentially grow the carbon across the whole landscape based on carbon dynamics that we derive from FVS, the Forest Vegetation Simulator. So basically what we do is we run all of the FIA data through FVS. This is basically a growth model that allows you to represent different kinds of change, disturbances, and managements. We run every FIA plot through that, and we're able to develop generalized carbon trajectories for every pixel or every stand in your national forest. And so we see the carbon responding to the disturbances that are mapped. And basically what we do is we map and account for the carbon changes that have resulted from disturbances. Then we run FORCAMP and simulate no disturbances. And the difference between carbon storage under the disturbance scenario and with no disturbance gives us an idea of how important each type of disturbance really was in terms of controlling the amount of carbon storage. And so for each national forest as well, and it's also reported at the regional level, we see the relative impact. That's really what FORCAMP is best at, is showing you the relative impact of different types of disturbance on your forest or in your region. So in the National Forest of Florida, for instance, if you focus on the pie chart, we see that fire is a little bit more important than harvest, at least from the period of 1990 to 2011, which is the period that FORCAMP was applied for these reports. So that's the biggest take-home message. The results on the left give you a lot more context about how that contribution has evolved over time. So the x-axis there is time, and the y-axis is the difference in carbon storage that is attributable to each type of disturbance. And so, if I was to help you interpret this, there's a fairly steady impact of harvest right from the beginning, right from 1990. We didn't get much fire activity until about 1996, and there were a few years there where there were important fires, and actually together they over the entire period, those important fires pushed the impact of fire above the impact of harvest. And what I want to say is that FORCAMP, the impact of a fire or any individual event is felt far beyond, in terms of time, far after the event actually happens, because what's happening under the hood of FORCAMP is that trees are being killed, but the carbon in those trees is not immediately emitted. So the impact of a particular fire that you might see in 2005, that gray line is going to continue to go down. And remember that the y-axis is the difference between the disturbance scenario and a no disturbance scenario. So relative to that nice healthy stand, if it had been left healthy, that difference is going to increase. The impact is going to be felt like it is in reality far after the actual fire. Okay, so here again we have a side note that will help you connect the results that you see in the reports to frames of reference that people will understand. So the y-axis in the FORCAMP graphs in the second report is grams per square meter, which is, I'll admit, not particularly intuitive. But I think we've given you the conversion factors you need to go from that to metric tons, and then from metric tons to barrels of oil. So, for instance, on the y-axis in this graph, if you see 200 grams per square meter, that's also equal to 2 metric tons per hectare. And you can get these conversions also, by the way, just typing them into Google. So, using the conversions to petroleum impact, for instance, that I showed in the first video, if the unit was 500,000 hectares, which is about average, an impact of fire or harvest would be equivalent to about 8.5 million barrels worth of oil. So that is 8.5 million barrels of oil that are not being stored on the national forest because of fire or harvest or whichever line you're following. So I'm just trying to give you a crib sheet for turning the numbers that you see in the report into things that your users can relate to. This is also a graph that's in each of the reports at the regional level, but it summarizes each of the national forests. We're looking at Region 8, the southeast or the southern region. So basically what we've done here in these graphs is compare what FORCAMP says is the impact from 1990 to 2011 of different types of disturbance on the amount of carbon that is stored in each unit, and compared it to how much carbon is stored. And so basically these are percentage differences associated with each kind of disturbance on each national forest. So if I was to look at this, I would say that in the southern region, harvest is consistently important throughout the region. I'll point out that Hurricane Hugo, which happened in 1989, you do not see the impact of that because our first year was 1990. You would probably see a pretty big signature in the Francis Marion under wind if we had started in 1988, for instance. And lastly, just sort of put it all in a nutshell, if disturbances in this region had stopped in 1990, carbon stocks would be about 8% higher across the region. I want to point out, and I've said this earlier, that not all of these disturbances, in fact, most of these disturbances might have happened with or without us. You know, they're not all, especially the fires, are not all attributed to our management. And this graph also shows you the relation between, for instance, harvest and fire, and allows you to tease out the relative impacts of the different types of disturbance. So that's really what FORCAMP is for, is to look at the relative impacts of different types of disturbance and management. Okay, so the last level, probably the most complex level of question that we might ask about carbon on each national forest is, how does the effect of management and disturbance, which we just looked at through FORCAMP, how does that compare with the impact of global processes like the composition of the atmosphere and what the climate is doing? And that is not the kind of question that a design sample like FIA, relatively simple, can answer. You need a process model that explicitly looks at these kinds of factors. And so that's what INTEC is. And if you remember earlier, I said that we chose INTEC, which is an ecosystem process model, specifically because we can calibrate it with really, in important ways, with the same kind of empirical data that is really buttressing the other tools. Okay, so just to introduce you to INTEC, Integrated Terrestrial Ecosystem Carbon Model, it's a process-based model, so it's allowing a representation of different ecological processes, growth, respiration, that kind of thing. It allows us to consider the impact of the atmosphere and of climate, and I guess I've already said that it's very close, our use of it anyway, is very closely calibrated with FIA data and with the disturbance maps that I talked about, and also FVS is used with FIA data to calibrate the rate of growth that goes, and mortality that goes into this model. So I'm not going to delve too deeply into the guts of the model, but I'm just going to highlight that the fact that it is very empirically calibrated with population FIA estimates, a lot of the same kind of FVS simulations of FIA data that underlie FORCAMP, the disturbance maps, and the downscaled local climate data. So the graphs that you see here are presented at the regional and the national forest scale in the second report. And we've already seen the bottom kind, that's just distribution of age by forest type for each national forest. And that's combined with FVS data, we also get basically the top one is growth rates at different ages. So, that might be important information for projecting, timber if we were monitoring timber, but we're using it for understanding the growth of the accumulation of carbon. And so, the take-home messages you might get if you looked at the report and this was your forest, most stands are older. There was a peak in stand establishment, in the early 1900s. Stands are most productive when they're about 25 to 60 years old. You might know that. You probably know this, especially if you're a regional silviculturist. You probably have a good idea about this for your region, but maybe it would be useful to have very data-driven evidence of that. There's a large peak in young stands due to recent large fires. And these young stands will be reaching, if you put these both together, these young stands will be reaching maximum productivity in coming decades. Okay, so to get to the results of INTEC itself, this is really sort of the money graph that you will see in the second report for INTEC. And you'll see this graph both for at the regional level and the forest level. And so, the y-axis is really the impact on carbon accumulation. And basically, if it's trending above zero, that means that that factor is increasing carbon stocks. And if it's trending below zero, that means it's decreasing. So the nice thing about, or the reason we're going into ecosystem process models at all, is because we can look at a lot more factors than a simple inventory-based approach will give us. So with that in mind, if this was your national forest, take-home messages you might get here is that climate has caused a decline in accumulated carbon due to warming temperatures and a decline in precipitation. Also, forests are aging, and there have been recent large disturbances causing disturbance to cause a decline in carbon stocks. So, we're seeing both the age structure and disturbance cause a decline. On the other hand, balancing to some degree the climatic effects, carbon dioxide fertilization, there being more carbon dioxide in the atmosphere, which is obviously an input to photosynthesis and maybe speeding up growth. And there's also been more nitrogen deposition, have partially offset some of the negative climatic factors. So this is sort of pulled apart at the national scale. And I think the really nice thing is that we also, I think it's the purple line. FORCAMF gave us an idea of how important disturbance has been, and this puts disturbance into context with other global factors that we probably do not control at all. The atmospheric and climatic conditions, as well as the age structure of your national forest. So in this video, what I've tried to highlight is that there's an order of precedence. There are basically 4 tools presented across these 2 reports. And I think that using the best available science dictates that for whatever question you're asking, you want to be to the right of this graph. You want to use as much locally collected and representative empirical data as you can to answer your specific question. And I'll just remind you that you could use INTEC, for instance, to answer that first question, how much carbon is on the landscape. But you probably wouldn't, because there is something available to the right of INTEC on the graph that's appropriate for answering that question. So we really want to pick the tool that's presented in these reports that best fits our question. So to summarize, the first bullet is basically what I just said. Using the best available science for each carbon-oriented question you've got, you want to be as far to the right on that graph as you can. You want to use as much local representative monitoring data as you can find. The carbon story, and this is a point that I really made in the first video, the carbon story must be interpreted in light of the bigger picture of the forest. You know, the results in these reports should not be interpreted in a vacuum. And there are lots of scenarios you can imagine where there are short-term losses in carbon that might or might not result in longer-term stability of carbon. So, and it's impossible for us producing nationally standardized baseline reports to be able to get into all of those stories, but I think that it is probably the local managers who are most qualified to fill that role. And so hopefully you will see these results as a menu of carbon information that you might choose to help tell the story of what's happening on your forest. And that's really what you need for the forest planning process. And lastly, in this video, I've gone through a lot of the data that we've compiled for this carbon monitoring process. It might be useful for other kinds of monitoring, and my contact information is down there. We are planning some applications to distribute this in a way that I will not be directly involved, but and I'm sure that you will hear about, it'll basically be web-based. You'll hear about that when that's developed, but until then you can contact me and my information is given there. So yeah, look forward to hearing any questions you might have, and thanks.